Okay, so today in class, we talked about functions and these things that we can do with those functions, namely f plus g of x. We could add functions together. F minus g, we can subtract functions. F times g, f divided by g, f composed with g, which we'll talk about in detail, g composed with f, and f composed with f. And so first of all, let's just take one of these on each of these upcoming pages. Let's do f plus g of x. What you want to do when you see f plus g of x is just add x and g together. So x plus 1 is the f function, plus x squared minus 2 is the g function. Now the final answer is the simplified version of that. So we would say that that would be x squared plus x, and then like terms together would be minus 1. That's all there is to that. Okay, so now we're going to do f minus g of x. And a mistake that can easily be made in doing f minus g of x is to do it kind of just like you see it there by saying x plus 1 minus x squared minus 2. We don't want to do that because to subtract means you have to subtract everything that is in g, meaning that the x squared needs to be subtracted and the negative 2 needs to be subtracted. So being very cautious here, we should have done this. We should have done f minus, in parentheses, g. And now it becomes a little bit more obvious that it's x plus 1 minus x squared, although plus 2, because minus a negative becomes positive. So then we can just write negative x squared plus x plus 3. And that would be f minus g of x. So now we're going to look at f times g of x. And to do f times g of x, you do just that. You write down f in parentheses and g in parentheses and use the idea of foiling, or just make sure x gets to meet both of these through multiplication and then 1 gets to meet both of these through multiplication. So let's start with x meeting x squared. X times x squared is x cubed. Then x times a negative 2 would be negative 2x. Now make sure 1 gets to meet x squared, and you'd have a positive 1x squared, and 1 gets to meet negative 2, so you'd have a minus 2 at the end. So now you can just combine like terms, x cubed plus 1x squared minus 2x minus 2. Now notice there weren't any like terms to combine, but we do kind of call it simplified when all of the exponents decrease in power. So the fact that we now have it written as a cubed and then a squared and then a raised to the first and then no x's, that's kind of the preferred way to write those. Okay, so now we're going to look at f divided by g, and f divided by g is basically just that. It's f written on top of g. And since there's no simplifying that can be done here at all, that's it exactly, just left simply put that way. Okay, there's two notations here that mean the same thing. This is read as f composed with g of x. It's kind of, people read it as fog, but that would be incorrect. F composed with g of x. Now this is also that very same thing written in a different notation, but I like this one better, although we don't see it as much in our textbook. But this clearly shows that g of x is inside the f function. And so that's exactly what this composition means. It means take g and put it into f. So wherever there is an x, it now becomes whatever the g function was. So since it's x squared minus 2 is the g function, we're going to write that inside of the f function. And then the parentheses here aren't really doing anything, so it's just simply x squared minus 1 in a simpler format. Okay, one might think that g composed with f of x might be the same thing, and sometimes it is, but very rarely, and it'll actually mean something to us if we find that out later in this class. But for right now, g composed with f can be thought of as g with f put in it. And so we're just going to take the f function and put it into the x of the g function. So it would be parentheses x plus 1, that is indeed squared, and then minus 2. And one could argue that that's pretty simple, or we may want to FOIL this out and simplify it down even further to get a real simple version. So x times x is x squared, however x times 1 is 1x, 1 times x is 1x, 1 times 1 is 1, and therefore we have x squared plus 2x minus 1. And that would be the simplest possible way to say that. Now, kind of a strange idea is f composed with f of x, which basically doesn't involve g at all, and you're just going to take x and plug it back in for x. So it would look like this. It would look like x plus 1, where there used to be an x, plus 1. And so in this case, f composed with f of x is just simply x plus 2. Okay, in everything we've looked at so far, this had always said f plus g of x, or f minus g of x, or f times g of x. But it is possible for something to say f plus g of 2. And there are two approaches you can take to that. You can add the f and the g function together like we did earlier. So f plus g of x would be x plus 7 plus x squared. In other words, it's x squared plus x plus 7. And then when you want to know f plus g of 2, just simply make all of the x's 2 in that problem and see what you get. Well, that'd be 4 and 2 and 7, so that would be 6 plus 7 would be 13. So we have f plus g of 2 is 13. Another approach to these is to take the 2 and first find f of 2, then find g of 2, and then simply add those answers together. And that's sometimes the preferred method because you're dealing with numbers more often than the letters we did in the previous example here. So I might say 2 plus 7 is 9, and 2 put into the g function is 2 squared is 4, and then I would want to do what it said here by adding them together, and so the answer is 13. You can see it doesn't really matter which viewpoint you take, and the answer is 13. But I do know that in a lot of cases, people prefer to avoid dealing with x's and would much rather deal with the numbers right at the beginning. So it's really your choice. Hey, I know class has been kind of hectic the last few days. It's kind of bothered me too about being here sometimes and not being here the others, and then being pulled out for writing tests and things like that. But hopefully I've given you enough here that you can get the assignment done, and then not only that, but have an understanding of what you might see next week on the test. So to practice today, make sure you go to page 89 and work on 5 through 23 odds. And check those answers in the back, because one of the most challenging things is going to be if you have it all the way reduced or not. And so make sure you're matching the answers in the back. And if you're having difficulty doing that, then bring those to class when you have a chance and ask about those situations, and I'll gladly try to clear that up for you.